All right, let's talk about something really critical, AI safety. We're building these incredibly powerful systems, but how do we make sure they're actually safe? Well, it turns out the past has a lot to teach us. We're going to dive into how some major technological disasters are giving us a roadmap for building reliable AI and, securing our future.
Safety doesn't sell. Just think about that for a second. I mean, wow, that's a pretty chilling thing to hear from a former president of Ford, right? And it gets right to the heart of this tension that has caused actual catastrophes. It's this constant battle between the pressure to be first and the need to be safe. And you better believe that same tension is playing out right now in the world of AI.
And this isn't just a one-off thing. We've seen this exact pattern play out time and time again. I mean, look at the Ford Pinto back in the 70s, then the Challenger shuttle in the 80s. And it's not ancient history, right? The Boeing 737 MAX was just a few years ago. It's the same story. Companies get into this high-stakes race to win, and safety? Well, safety ends up being the tragic casualty.
And now, a brand new race has started. When a CEO says a race starts today, we're going to move fast, especially at the launch of a new AI search engine, that's a huge signal. It's like history is rhyming. Those same intense, high-stakes competitive forces that we just talked about, they are absolutely the engine driving AI development right this minute.
So the big question is, how do we avoid making the same mistakes all over again? Well, here's how we're going to break it down. First, we'll look at what it means to be racing into danger. Then, we'll open up a toolkit for safety. And finally, we'll tackle how to go about expecting the unexpected.
All right, let's jump into our first section, racing into danger, and see how these past failures can really shed some light on the risks we're facing with AI. So, what's the common thread here? Well, sometimes it's that intense competition, like with the Ford Pinto. Other times, it's just straight-up cost-cutting, which is what led to the horrific Bhopal gas tragedy. And sometimes, like with Chernobyl or the Challenger, it's not even about a race. It's just organizational carelessness. But you see the pattern, right? No matter the cause, the result is the same. Really complex systems fail in truly catastrophic ways when safety isn't priority number one, period.
And this quote, this just perfectly nails the mindset we're seeing right now. This idea that it would be a fatal error to worry about things you can fix later. That's the whole move fast and break things mantra in a nutshell. And look, that might be fine when you're building a new photo sharing app, but when we're talking about AI, the stakes are just monumentally higher. It's a completely different ballgame.
And here's what's really wild when you think about it. Back in the day, with nuclear power and rockets, we had a pretty solid grasp on the physics, right? The theory was well understood. With AI, it's a different story. We're building something where the inner workings are often a total mystery, even to the people who created it. It's kind of a black box. So we have this technology that's way less understood than a nuclear reactor, but the pressure to roll it out everywhere is just as high, maybe even higher. That's a pretty potent combination. Okay, so it's not all doom and gloom. There are ways to handle these risks. Let's get into Section 2, a toolkit for safety, and look at the engineering principles we can use in this high-stakes world. The foundation of all of this is actually a pretty simple equation. See, risk isn't just some vague, scary word. In engineering, it's very specific. It's the probability of an accident happening multiplied by the severity of the harm it would cause. Understanding this helps us figure out where to focus our energy.
Okay, so one of the most important tools in the toolkit is the concept of a failsafe. The whole idea is to design systems that are safe even when they break. The classic example, right, is an elevator. The emergency brakes aren't held back by electricity. They're held open by the tension of the main cable. So if that cable snaps, the primary failure, the tension disappears, and bam, the brakes automatically slam shut. The failure itself triggers the safety mechanism. It's brilliant.
But here's the thing, no single safety system is foolproof. Nothing is perfect. And that's where this next idea, the Swiss cheese model, is so useful. I love this analogy. Instead of thinking of safety as one big solid wall, picture it as a stack of Swiss cheese slices. Each slice is a layer of defense, but each one has holes in it, weaknesses. So what are these layers? Well, you could have a layer of really robust training data, then another layer of red teaming, which is basically where you pay experts to try and break your system on purpose. Then you've got anomaly detection, and of course, a layer of human oversight. The key is that while every layer has holes, a catastrophe only happens if all the holes in all the slices line up perfectly. The goal is to make sure that alignment is practically impossible.
And to organize all this thinking, we have something called the bow tie model. It's a great visual. In the middle, you have the bad event you want to avoid. On the left side of the bow tie, you list all your preventative measures, everything you do to stop the event from happening in the first place. And on the right side, you list all your protective measures, what you do to minimize the damage if, despite everything, it still happens. It forces you to think about both prevention and mitigation.
Okay, but all of this relies on us knowing what the risks are. What about the dangers we can't even imagine? The real curveballs. That brings us to our final section, expecting the unexpected, and how we navigate a world of black swans.
So, in the world of safety engineering, there's this concept of tail events, and these are the big ones. They are super low probability, but their impact is just immense. We're talking about things like the 2008 financial crisis or a global pandemic. These are events where our standard way of thinking about risk, relying on averages and what's happened before, just completely falls apart.
This really gets to the heart of it. Most of life happens in what you could call a thin-tailed world. A single event, like one person being really tall, doesn't dramatically change the average height of everyone. But some things exist in a long-tailed world. Think about wealth. A single billionaire can dramatically skew the average wealth of 1,000 people. The worry is that AI doesn't operate in our normal, predictable, thin-tailed world. It might operate in a long-tailed one, where a single, bizarre, extreme event could be more important than everything else combined.
In this turkey analogy, it's just brilliant for explaining this. Picture a turkey. Every single day, a farmer comes and feeds it. From the turkey's perspective, based on all the data it has collected, this farmer is a wonderful, benevolent creature. The turkey's model of the world is perfect, until the day before Thanksgiving. Suddenly, a brand new context is introduced, and its entire worldview is shown to be catastrophically wrong. A perfect safety record means nothing when the fundamental rules of the game change.
That event, for the turkey, is what's known as a black swan. It's an unknown unknown. It's not just that it was unlikely, it was completely outside the realm of what the turkey could even conceive of. It revealed that its whole model of reality was incomplete. And that is the billion-dollar question for us, isn't it? What are the black swans for AI? What are the unknown unknowns that we aren't even capable of imagining right now?
So I'll leave you with this final thought. If someone told you a river had an average depth of 4 feet, would you walk across it? Sounds safe, right? But what if that average hides a sudden 20-foot deep hole right in the middle? When we're dealing with technologies this powerful, technologies that have the potential for black swans, focusing on the average isn't just misleading, it's a recipe for disaster. We have to think about the extremes. We have to plan for them, and we have to build for them.